Okay. So let's say I have this. What I'm going to do is I'm going to make a matrix out of this. Okay? Where I'm going to take this matrix and I'm going to put the x value on the top and the y value on the bottom. -3, 2, 4, 0, 2, -2. Okay? That's a matrix notation for this. You see what I did? I did x up here, y here, x up here, y down here, x and y. That's just a smudge on the board. Okay, now let's say I want this to be dilated by a factor of 2. Then what I'm going to do is I'm going to do scalar multiplication on it. And what I'm going to have is I'm going to have -6, 4, +8, 0, +4, -4. What that gives me is the ordered pairs for the figure that's twice this size. So I'm going to come over here and I'm going to graph -6, 4. So if this is A, this becomes what we call A prime because I've done a transformation on it. Then 4, 0 becomes 8, 0, which is right here. So I'm going to call this B prime if that's B. That's like B once something's been done to it. And then the 2, -2 becomes 4, -4, which is down here, which if this is C, then this is now C prime. And what you see is we dilated or expanded by a factor of 2. We made it twice the size. Okay? So that's one way that you can use a matrix. If you remember back in Algebra 1, we talked about translations, and we talked about reflections, and we talked about rotations, and all of those things we can use a matrix for. Okay? Now, I'm not really sure I would have done that, because all I know if I'm going to multiply it by a factor of 2, I just multiply each of these things by 2. That's what I did over here. I just happened to put it in a matrix form. I don't know if that would have been worth it, because in your head you could have gone, oh, that's -6, 4. So there's -6, 4. 4, 0 becomes, oh, that's 8, 0. Okay, I don't know if I would have done that, but you can do it that way. All right, let's talk about adding and subtracting matrices. So right now we've done scalar multiplication with them, where we just take a number at the front end and we multiply it by everything in the matrix. Okay? In order to add two matrices, they have to match up rows and columns. So if the first matrix has 3 rows and 2 columns, okay, so 2, 0, 4, I'm just making up numbers. Okay, that's 3 rows, 2 columns, right? In order to add a matrix to it, it also has to have 3 rows and 2 columns. So I can take these, because they match up, same number of rows and columns, and I can add them. It's very simple to add them. I just take first row, first column, add it to first row, first column. So my resulting matrix, so let's say this is A and this is B, then this maybe is C. It really doesn't matter, but okay, so I have a 2 and I have a 0, because 2 plus 0 is 2, -5 plus 5 is 0. We good with that? Okay, so this is -2, this is 17, this is 8, and this is -1. Okay, everybody with me so far? There's nothing hard about this. What if I have a minus in front between it? Then what happens? I'm going to subtract each one. Now, there's definitely been some students that they prefer to add the opposite of the second number. So what they'll do is they'll go through and they'll make that subtraction a plus, and then make these all opposite signs. If you want to do it that way, you can do it that way. But understand, each one of these is subtraction. So you can turn around and go, 2 minus 0 is 2. -5 minus 5 is -10. 0 minus a -2 is what?
2.
+2. 7 minus 10, -3. 6 minus 4 is 2. 6 minus a -6 is 13. If they try, let's say they tried this one on you. and they said subtract that. What would the answer be? Empty. Yeah, okay, you can just turn around and you can do this, or you can say not possible, impossible, somehow tell me it can't be done, okay? All right, obviously they take this and they can complicate it a little bit because they can put the scalar multiplication with your addition or subtraction. Make sure you do the scalar multiplication first. You know, like if you had what would you have to do first in this problem? I'd have to distribute, just like you have to do scalar multiplication first with the matrix, okay? So I'm going to put one up here, and I want you to try it. Okay. I might have to make it up. Let's see. All right, do that one. Now, if I were you, right here in the center, I would add the opposite of the second number. So I would be taking a negative 2 times every one of them. I think that's the easiest way to do that. Yes, no, maybe. Joseph, yes, no.
Most of them.
Most of them. Okay, I do think it's easier. It's easier if you just go ahead and multiply it. I would bet the mistake came right here. Because what I did was I go, oh, I'm going to change this to addition. And I'm just going to act like I'm multiplying negative 2 times every one of them. Do you understand why I did that?
Mm-hmm.
Just by adding the opposite, then I'm taking negative 2 times everything. And I found that to be easier. if it's a mistake, it's probably a mistake with positives and negatives. Okay, the concept is easy. There's nothing to the concept. Okay, we're gonna pause right here. Okay, now instead of doing homework right here, we're gonna do classwork. Okay, because we still got plenty of time. But multiplication's harder. Okay, so right now, do this. And I promise you have a cold. Okay. Everybody, when you cough now, everybody's like, oh. All right, page 191 through 192. And this is classwork, not homework. Okay, that's just the basic matrix stuff, and then this is the addition part of the matrix, and then we're gonna go on to multiplication. But multiplication is kind of messy. There's not a whole lot right there. And Michelle, you're gonna have to do that and turn it into me.
Yeah, calculating.
Yeah. 1 second. Stop this for